What's up, guys? So, today we're gonna deep dive into something you must understand about variables. We're going beyond, obviously, the basics, but we will cover the basics for review. So, we're gonna talk about the two kinds of variables found in Java, primitive types and reference types, how memory works, and how this all correlates. So, yes, variables, they store two type of things, primitives and reference. They are used in two places, well, more than two places, but for now, let's focus on two. Object state and local variables. The other places you might use them are arguments sent to a method and return types, values sent to the caller of the method. So, yes, primitives. I'll write some basic notes here for you guys. So, primitives. Primitives hold fundamental values. So what are fundamental values? They are simple bit patterns. So for example, integer, Boolean, and floating point numbers. So yes, the number 7 is represented by a certain bit pattern of zeros and ones. And yes, this is the variable. It holds the number 7 represented by the bit pattern of whatever combination of 0 and 1. Awesome. So let's see. So a variable is sort of like a container, like a labeled cup for storing data. In Java, every variable stores either a primitive value, like a number or Boolean, as I said, or it can store a reference to an object. So reference, what is a reference to object? Object references. So object references hold references to objects. Easy says it. So yes, this is a very simple idea. So um let's see. Starting with the primitive types, let's cover some basic stuff. Um, so, as I said, they hold fundamental values, simple data like numbers, characters, or booleans. Yes? So, the primitives have a sizing. Each primitive has different size, as I said, like cup size, and each size has a name. The size represented by name, and each variable of this size has name, so it must be each variable is declared with a specific type. The four integer primitives are long, int, short, byte. Okay, and then each primitive variable has a fixed number of bits, as I said, the cup size. So the sizes of the six numeric primitives are byte, short, int, long, float, double. And this is an order of the like least to greatest size in a sort of way. For the integer types, it's from shortest least to greatest sizing. And then for float and double, they're also in that order because float is 32-bit and double is 64-bit. Okay, so these are the primitive types in Java for the most part. Other ones is char. Okay, so you have byte, short, int, long, float, double, char, and boolean. Okay, so other ones is char and boolean. So as I said, each primitive has a specific size. So byte, 8 bits, short, 16 bits, int, 32 bits, long, 64 bits. So these are the four integer primitives, so they're integers. Yes. So, and moving on to float, 32-bit, and double, 64 bits. So keep in mind, float and double are numeric primitives because they hold decimals and not integers, so they're two decimal types. So decimal and decimal, the decimal types. So char and boolean are a little bit special. They're different, but they still have fixed sizes. So we'll take note of that. So some rules to remember are that you can assign smaller types into bigger ones, like byte into int. Java calls that phenomena widening. We cannot go from big to small without casting, which is a way to overwrite, okay? Even if the value fits. Because Java, it does not really see the values of your variables. It just knows that, like, it doesn't want to take this risk of going from a small type, from big type into small, because there's a possibility for spillage present in big to small. And you can't expect the compiler to know the value you see in your code. So Java doesn't assume anything is safe. It loves to be safe. So assigning values. So assigning values, there's some ways to do this. You can do it with literal value, like int x equals 10. It's just literally assigning the value, just another way to put it. You can do it by copying another variable's value, like x equals y. Or you can do an expression, like in math, x equals y plus 3. Okay? Awesome. So also, variables, they can be declared first. So I can have integer score, right? I put my period here. Score is made, it's present, but does not have a value yet. So we'll do is next line, we can do score, the name of the variable, we give it a value later. Anywhere in the program, you can give it the value. But yeah, just remember, a variable must be initialized before used. Variable must be initialized before use. Awesome. So we've covered some very basic stuff now. It's key. And let's see. As I said, going from small size variable to big size variable, no problem. But keep in mind, the compiler always likes to play on the edge of safety. It does not take risks. So some special cases can arise. But yes. So I've covered the primitives quite well, I believe, for introduction purpose. So let's go on to references. Reference variables. So let's see. Let's see. When you create an object in Java, you don't store objects directly in variables. Instead, you store a reference to an object, sort of like a pointer. It gives a mapping to where the object is, right? So when I make an object like bottle from the class bottle blueprint, my bottle, which is the specific instance of the bottle, equals a new bottle, right? With the parentheses, of course, right? This bottle is stored in a special place, the heap. Yes, garbage collectible heap. You'll learn about this later on. The heap is where objects live. They live on the heap. It's this place where the pointer points to, because objects don't live forever. Every object around us has a start point and end time in the chronological order of time. So yes, they will die out eventually, be of no further use, trashed away, and that's when garbage collection happens and the object dies. So yes, variables they don't hold objects. So how do I explain this now? So bottle is the blueprint. My bottle is the reference variable, okay? And then the new bottle creates the actual object on the heap, okay? And then, so methods. When you call a method, for example, my bottle dot operator shrink, we're pretending this class is made, but it's not actually made, right? We, you're saying like, use this object to do something, because you never have an object variable, you have a reference to an object, okay? So yes, this is pretty much some basic coverage of reference. So I want to do some further information notice on the primitives, because we mentioned the bits of each, right, byte. So what values do byte hold? They go from -128 to 127, I believe. Short goes from -32,768 to, yes, 32,767. Integer, they're roughly a little over 2 billion, both the negative and positive way. Little over, both way, so negative by positive, yes. Long is huge, very big, very, very big. Float, let's see, it's roughly plus or minus 3.4 to the power 1038. So yes, that's the valuation. So it's based on 7 decimal digit precision. It's floating point, remember? Double is plus or minus 1.8 by 10 to roughly 300, I believe. So it's about yes, it's 15 decimal digit precision. Remember, it's floating point. But yes, no need to know the exacts, just roughly, okay? This will be suffice. Now, Boolean. So Boolean, it uses at least 1 byte in memory, not just 1 bit, due to the Java virtual machine constraints. But conceptually, it's just true or false. Okay, just no, it's conceptually true, false. And char holds a character. Example include A, B, C. Okay? Yeah, char holds a character. Awesome. But when you actually use char, you don't literally use double quoting, you use single quote like this. So you declare it like this. Char letter equals A. Like that. Remember your semicolon. Or with char, you could also use unisymbol, like Unicode decimal. Like, let's see, char symbol equals 65, and that's Unicode decimal value for A. You can research this on your own. Don't really need to know this. But yes, I gave you the sizing constraint for each of these primitive and numeric types. And yes, they're very simple to apply. Everything just goes like this. You use the type, let's say double, give it a name, double D, equals a floating point, because it's a floating point type, so just keep that in mind, and boom, this is how you do it. Name type, assignment operator, give it the number within the constraints and rulings, and yeah, very easy. So object references, we covered them somewhat. Remember, use the dot operator on a reference variable to say, use the thing before the dot to get me the thing after the dot, okay? Object reference variables, the bits represent how to get to an object. Primitive value, bits representing the actual value of the variable. So bit representation, you're having the, so you have the bits representing the actual value of the object. And then for reference object variables, bits represent to get to an object. Remember the dot operator? And then we sort of covered object declaration right here. Just an introduction. declaration intro. Let's see. So the bottle points to class bottle. The my bottle is the name of the reference variable. Java will be told to allocate space for the reference variable and names that reference variable my bottle. The reference variable is forever of the type bottle. Okay, so the reference variable serves sort of as a guiding point, and it has ability to control the bottle and call method, and then yes, you can call methods on the specific instance of the bottle. And when the object creation is done by new bottle, parentheses, which we'll cover why you need this later, and the semicolon. You always need them, but you don't have to use them. So this allows the JVM, Java Virtual Machine, to allocate space for the new bottle object on the heap where memory is done and managed, okay? And the linking is done by the equals operator, I'm sorry, assignment operator, which assigns the new dog. We're working with bottle now, so new bottle, the reference variable, my bottle. And the remote control or like guiding point has been programmed. So once an object is assigned with the reference using the singular equal sign, it is put into life on the heap. So life on the garbage collectible heap. What is this? So when you declare something like a reference variable and you make the objects on them new ones, they're created, right? The reference variables, but the reference variable doesn't hold the object. The object is held in a separate place called the heap. And I'll cover this later, but yes. Okay, awesome. So remember, you can do all this stuff. Take notes. I will leave here for a little bit. You can pause, take good note, keep it in mind, and yes. So here's this part for you. And then here is the rest. Okay, you can pause that, take note. Cool. Thank you. Yes. These are very fundamental stuff to know.